Thank you for watching this project help video for lesson 19. I will help you answer each question in the project by providing step-by-step instructions using example problems. A good strategy might be to pause the video after each example and then work the corresponding problem in the project. Let's get started. Question 1. The following arithmetic sequence represents the points scored based on the number of three-pointers made. What is the common difference of this sequence? And so remember, common difference applies to arithmetic sequence, and it's talking about what we have to add or subtract to get from one term to the next. Right? And in this case, we are adding 3 each time, right? You're just looking for the pattern. What is the pattern? And here it is 3, 6, 9, 12, 15. So it's pretty easy to see that we're just adding 3 each time in this example. So what is the common difference? 3. Right, so it is that simple. Remember, this 3 has nothing to do with this first value in the sequence here. It's not because this is a 3. It's because what I'm adding each time to get from one term to the next is 3. Right? That's what we call the common difference. Right? Because all those differences are 3. Well, I mean, it says it, right? Common difference. What you're adding or subtracting to get from one term to the next. All right, so the arithmetic sequence from problem 1 can be written as a linear function. What is the rate of change or slope of this linear function? All right, so we could go ahead and we could actually write out the explicit formula for the sequence if we wanted to. And then, since it really is analogous to the equation of a line in slope-intercept form, we could look at the coefficient for our input variable, n or x, whatever we decided to use, and bang, that would be the rate of change or the slope. But we don't have to do that, right? That would be more work than we need to do. Is what you need to know, and is what they really, really would like you to know in this lesson, right, and this unit, is that rate of change, or the slope of a linear function, is analogous. That means the same as the common difference for an arithmetic sequence. All right, so let me repeat that because that's a big idea. The rate of change of a linear function, the slope of a linear function, is related to, right, is the same as the common difference in an arithmetic sequence. So from question 1, we can see that the common difference for this sequence was 3. And then so what is the rate of change or slope for the linear function? It is 3. Right? I bet that was a lot easier than you thought it was going to be. Right? So don't make these questions harder than they have to be. Rate of change means common difference. All right, so what is the function rule for the arithmetic sequence defined in question 1? Okay, so now we actually have to write out the explicit formula. Right? That's going to give us our function rule. All right, so I start with the formula, the explicit formula for an arithmetic sequence, which says a sub n is equal to the value of the first term, and this is how we write that, a sub 1, plus the common difference, which we denote as d, times the quantity n minus 1. Remember, an n is referring to the term number again. It is our input variable. All right, so in order to write out this function, we need to know 2 values. One, a sub 1, the value of the first term. All right, so that does mean first term. And then the d, which means our common difference. And those are easy to find looking at the sequence in this case. I'll finish writing this out. All right, so the first term, well, look, there's the first term. It's the first number in the list. So the a sub 1 means that the value of that term. So we would say that a sub n is equal to 3 plus the common difference. And the common difference in this case is also 3. It's not always the same as the first term. In this case, it happens to be the same. And that's because remember that the sequence represents the number of points you score based on the number of three-pointers you make. That's what the n is representing. So if you make one three-pointer, you score 3 points. If you make two three-pointers, you're scoring 6 points, and so forth. Okay. Now we just go ahead and simplify this function. We can do that here by distributing our common difference across our n minus 1 term here. So we get 3n, in this case minus 3. And then we go ahead and continue simplifying. So in this case, it just turns out that I combine our numbers out here. Those are like terms, right? So I'm going to leave my 3n, and 3 minus 3 is 0. So I could write plus 0 or just leave it as 3n. Now, if you wanted to write it using function notation, as you might see in your project, they might say f of n instead of a sub n. They might write it as f of n. In this case is 3n. Remember, in whatever you're doing in your project, you're going to have to get the first term and the common difference and then simplify in the same way, and you'll get a function. Another way that I could also check, right, if the function that I have written here does in fact define the sequence, right, is I could start plugging in term numbers for the n and see that I get the appropriate output. So for example, 1, 2, this 12 right here is the fourth term in my list, right? So that's like saying when n is equal to 4, I should get the answer 12. And sure enough, right, if I plug in a 4 right here, 3 times 4 is 12. Oh, it worked. And it has to work for all of them. So I could, if I wanted to see if, I can generate that 6 right there, well, that's the second term. So that means plug in a 2 for the n. Okay, so 3 times 2 is, in fact, 6. Oh, yeah, it's working. And that makes sense, right? Because remember what this function's representing. Points based on how many three-pointers you make. Well, yeah, if you make two three-pointers, you score 6 points, right? If you make three three-pointers, you score 9 points, and so forth and so forth. All right, so the number of points scored by Kevin Durant in the 2016 season can be modeled by this function. F of x is equal to 3x plus 1204. X represents the number of three-pointers made. Okay, so what do the numbers 3 and 1204 represent in the context of this situation? All right, so again, we're looking at a linear equation, right? Or an explicit formula for an arithmetic sequence. Think of those as being analogous to each other, right? Any arithmetic sequence can be written as a linear function. And this is written in function notation, but you should recognize it as y equals mx plus b. Okay, so we've been talking about the fact that the m here is the slope or the rate of change. And the b is the y-intercept or the initial starting value of something. All right, so in this case, the 3 in this front of the x here, that's our rate of change. So what's changing? Well, let's look and see what x represents and what the y represents, the inputs and the outputs. So if you're trying to kind of figure out what it's representing, well, slope is y over x. So think about what the units are for y and x, and you'll have your answer, right, about what that slope represents, right? Because that's our m, our actually change in y over change in x. Okay, so the y, our output here, is the number of points scored by Kevin Durant. So it's like points scored. So points per what? So remember the word per implies a rate, or to be multiplying or dividing by something. Points per, and then we got to see what the x represents. And then in this case, number of three-pointers made. Points per three-pointer, per one three-pointer. Okay, so that's kind of silly. Any of you that watch basketball, of course, know that a three-pointer is worth 3 points. points per three-pointer. Well, one three-pointer is 3 points. That's why that 3 is there. All right, so now what about the 1204? All right, so let's think about what the function's representing. Well, it's the total number of points that Kevin Durant scored during the 2016 season. All right, so if I were to actually be graphing this, I'd have a y-intercept. Remember, that's our initial something. It'd be like saying he had 1,204 points, and then we add to it all the points here that he's making per three-pointer, and we'd have his total points. So in this situation, it's a little bit different than you might have in your project. This 1204 is kind of representing all the points that he's scoring other than three-pointers. So it's all his field goals, all his two-pointers and his free throws, right, or foul shots.